Hello everyone and welcome to ACAD-10, which will be an introduction to tower control. So let's jump right in. First, let's talk about tower's area of responsibility. So tower or air control, they cover the boundary between the ground and the air. So on the ground, their responsibilities are the active runways and the respective holding points. And traffic here is generally received from ground control once the aircraft are approaching the holding points and all of the ground conflicts are eliminated. Then in the air, we think about tower as having the airspace immediately surrounding the aerodrome. So in this case, this becomes the mats when aircraft have the aerodrome in sight, or once they are established on an IFR approach. So before aircraft actually depart and they are still holding short, many aircraft have departure checks to complete, so are not always ready to depart once they reach the hold. They will often indicate that they are ready by calling ready for departure. If you give them a clearance and they say, or an instruction, and they say that they are not ready for it, you can also tell them to report ready for departure. You will note that we never ever talk about takeoff or landing unless we are explicitly talking about takeoff and landing. So it is always either departure or arrival before then. The only times you should use takeoff and landing is when you are clearing an aircraft to do so. Then once aircraft are ready to depart, we quite often move into this pre-departure maneuvering phase, where the aircraft will line up on the runway, but won't actually depart. And these clearances are typically given as the aircraft's call sign, the runway, and the clearance. So in this case, Hornet 1 via Charlie 1, runway 04 lineup. You can also give lineup and wait, which is occasionally more common, but they're the same instruction. So let's have a look at single runway occupancy. This is the concept where only one aircraft is cleared to use an active runway at once. So for a landing aircraft, the next aircraft will be cleared to use the runway once it has vacated onto a taxiway. And for a departing aircraft, the next aircraft is cleared to use the runway once it is airborne. So this, when I say use the runway here, we typically mean takeoff, landing, touch and go, stop and go, and so forth. And you can clear an aircraft to line up behind a landing aircraft or a departing aircraft before the preceding aircraft has vacated the runway, but you could not clear them to take off until they have. Speaking of taking off, let's have a look at takeoff clearance. So firstly, as we discussed in ACAD-2, except in cases of emergency, don't transmit to aircraft that are in the process of taking off, or then in the final stages of an approach and landing. These are very high workload areas for the pilots, so we want to keep their attention to flying the plane instead of effectively distracting them. We give a takeoff clearance by giving the runway or departure point for helicopters, the surface winds, and the words cleared for takeoff. Aircraft are only required to read back the runway or departure point and the words cleared for takeoff, and then obviously their call sign. They do not have to read back the surface winds. So an example could be something like Hornet 1, runway 04, the surface wind 04, 0 degrees 10 knots, cleared for takeoff. Then they come back, runway 04 cleared for takeoff, Hornet 1. We'll see an example of this later. We can also give aircraft what we call after departure instructions, and these are effectively what the aircraft is supposed to do after departure. We always give these as a separate transmission to avoid overloading the pilot, and they may not be ready to write these down, so we will quite often do what we would call a kind of ready to copy loop. So kind of Hornet 1 ready to copy after departure instructions, ready to copy, and then you give them the long message. We also always want to prefix these transmissions with hold position, just to make sure that they are an after departure instruction and not a do them now. So in this example we have Hornet 1, hold position, after departure fly runway heading, climb to altitude 5,000 feet, and then they read back, holding, after departure fly runway heading, climb to altitude 5,000 feet, Hornet 1. We tell them their readback is correct, and then in this case we are clearing them for takeoff on runway 12. Now let's have a look at this concept called route separation. So basically, aircraft that are flying in the same direction need to have some amount of separation between them so that they don't conflict in the air. And this is typically only required for IFR flights, because VFR flights will typically maneuver a bit more and can see other aircraft and can maintain visual separation. This is typically calculated using their SID, or departure direction, where aircraft departing on the same SID will typically require 2 minutes of route separation, and aircraft departing on different SIDs can be anywhere between 30 seconds and 1 minute, or potentially no separation, which all depends on how different the routes are and how close they are to going in the same direction. The specifics of this can be found in the DCP-15 series. Now let's have a look at landing clearance. So once aircraft are coming back to land, the radar controller will transfer aircraft once they are established on an approach, which can be either a visual approach or an instrument approach. Then at least at 4 nautical miles, you should check that the aircraft's gear is down, at which point it can be cleared to land. This is only required if they do not have fixed gear or skids, and should typically be reported by the pilot, but if it isn't, then you would prompt them for it. So in this case, Hornet 2 check gear down, report gear down, and then you clear them to land. The landing clearance can only be issued once the runway is clear and suitable for a landing. Again, coming back to the single runway occupancy. Landing clearance is issued over the radio in the same way that it is as takeoff clearance. However, the winds can be omitted if it is given previously. So, in this example, Hornet 2 runway 04 clear to land, and they read all of it back. Sometimes when you are checking in, and you can't give aircraft landing clearance straight away, you can give them continue approach and the surface winds, if they're on a straight-in visual or instrument approach. So, touch and goes. Touch and goes are where the aircraft touches down on the runway and will then take off again. This is typically used for pilots in the circuit to be able to practice their landings and practice practice lots of them efficiently even. This clearance is provided in the same way as a landing clearance, just using the words touch and go. So let's talk about the circuit. For fast jets, we tend to use this even oval circuit, just because the aircraft fly much faster and it keeps the circuit a bit closer into the aerodrome. In this case, we have a right-hand circuit because the turns are to the right, and the aircraft will report at 2 specific points. So number 1 here is the downwind call, so they'll report maybe Hornet 1's downwind runway 27 touch and go, or if there's only the one pattern, they can call just downwind touch and go. And at this point, you come back and give them the surface winds and any traffic that can affect them. So for example, Hornet 1 surface wind 270 degrees, 8 knots, 1 ahead, which indicates that there is, get my laser pointer right, there is the surface wind and there is 1 aircraft ahead of them in the circuit, but not yet on the runway. Then at point 2, they call finals, which will typically include their gear position. So it should be something like Hornet 1 final gear down. And this is then where you would typically clear them to land or touch and go. So how can we actually control the circuit and make sure everything works fine? Well, we have a few options to create separation. We can tell aircraft to extend downwind, where the aircraft will continue flying on the downwind until we tell them to.
Scorpion 1-1 ready for departure.
Scorpion 1-1 tower hello, runway 28, the surface wind is calm, cleared takeoff.
Runway 28, clear takeoff, Scorpion 1-1. Scorpion 1-1, downwind to touch and go.
Scorpion 1-1, the surface wind is calm, nothing to affect.
Scorpion 1-1, final gear down.
Scorpion 1-1, runway 28, clear touch and go.
Runway 28, clear touch and go, Scorpion 1-1.
Now let's have a quick look at managing flight strips as a tower controller. So when we are creating our profiles, we want to have a section which is specific to each runway. This will make it a lot easier to enforce single runway occupancy. And then on the right hand side here we have some strip markings that can be useful and are quite often used. Now let's have a quick look at coordinating with radar control. So for departures in VMC, we want to hand aircraft over to the radar controller upon leaving the mat. And in IMC, we want to hand them over once they are airborne. This is simply because most tower control should be done visually, by looking out the window, and if we are in instrument conditions, there is obviously little help that looking out of the window will provide you. So we want to hand them over to people with far better radar control tools than we do. Then arrivals. A radar controller will, if there are no standing agreements in place, will request an approach from the aerodrome controller, in this case tower control. So the coordination can look something like this: an APA, air, an APA, or this is even a handover of an aircraft, which again with LOT ATC is not necessarily applicable, but if you are doing more visually, you might want to just confirm these. So they will call for a handover, then they will give some details. So for example 11, 7 mile final visual approach runway 22, and then you would identify them either on your radar or by looking out of the window.